Potential energy of a dipole in an external field. Now we have a electric dipole containing two opposite charges plus q and minus q as shown in the figure. Twice L is the distance between the two opposite charges, and this dipole is placed in a uniform electric field E bar. Now direction of electric field is from left hand side towards the right hand side. Plus q charge and minus q charge are there for a dipole, so electric field will exert a force on both the charges. Force is exerted by the electric field on the charge plus q, and its direction is in the direction of electric field E bar. So direction of F1 is in the direction of E bar, and what is the value of F1? F1 is Q into E. Electric field also exert a force on the charge minus Q. Its value is F2 is equal to minus Q into E. But direction of force acting on the charge minus Q is opposite to the direction of electric field, because charge is minus q and electric field is also motion of electrons, and electrons are carrying negative charge, so there is a repulsive force is there, and because of that repulsive force, direction of the force acting on the charge minus q is opposite to the direction of electric field. Now what is then torque acting on the dipole? As there are two equal and opposite forces acting on the dipole, so torque is there. So what is the torque? Torque is P bar cross E bar. Product of, what about P bar? P bar is electric dipole moment. And what about E bar? E bar is electric field. So torque is P cross E. Now as there is a cross product between the two vectors, because P bar is also vector and E bar is also vector, so cross product of P bar cross E bar can be written as tau is equal to PE sine theta. This topic we have already discussed in the 11th standard electrostatic chapter. Now an external torque tau suffix external is applied, which rotates the dipole in the plane of paper from theta 0 to angle theta. अभी हम क्या कर रहे हैं? We are applying external torque on the dipole so that dipole is rotated from the angle theta 0 to theta. So we have a torque equation PE sine theta, and as we are applying external torque means we are performing a work. So work done W is equal to integration tau external of theta into d theta. So put the value of tau external, which is same as tau, which is PE sine theta d theta. Integration limits runs from theta 0 to theta. Now what is P? P is the electric dipole moment, it is a constant. Capital E, it is an electric field, it is also constant. So take P term and E term out of integration. So integration of sine theta d theta, integration limits runs from theta 0 to theta. Now if you solve that integration value, integration sine theta d theta, now we get minus cos theta, and limits runs from theta 0 to theta. Now put upper limit first, minus lower limit second. So we have a PE inside the bracket minus upper limit is theta, so minus cos theta is there, then minus, and again inside the bracket minus cos theta, lower limit is theta 0, bracket complete. So second term is minus of minus, so it becomes plus, and first term as it is minus cos theta. So we have PE cos theta 0 minus cos theta. This is our work done in rotating the dipole in the plane from angle theta 0 to theta. If initially dipole is perpendicular to the electric field E bar, then theta is equal to pi by 2 means 90 degree. Dipole कैसा है अब? Dipole is vertical and it is perpendicular to electric field. So theta is 90 degree. Then we have u of theta is equal to Pe cos pi by 2 minus cos theta. What about cos pi by 2? Cos pi by 2 is 0. So we have u of theta equal to minus Pe cos theta. But minus Pe cos theta, if you consider Pe cos theta term, then it is dot product of two vectors definition. A bar dot b bar is equal to ab cos theta. Similarly, we have a minus Pe cos theta. So one can write that RHS term as minus p bar dot e bar. If dipole is parallel to the electric field E bar, then theta 0 is 0. So we have work done means potential energy U of theta is equal to Pe cos 0 minus cos theta bracket complete. What about cos 0? Cos 0 is 1. So we have potential energy value U of theta is equal to Pe inside the bracket 1 minus cos theta bracket complete. Now let us consider example 8.14. An electric dipole consists of two opposite charges, each of magnitude 1 microcoulomb, separated by 2 cm. The dipole is placed in an external electric field of 10 raised to 5 Newton per coulomb. Find first maximum torque exerted by the field on the dipole. Second, the work the external agent will have to do in turning the dipole through 180 degree starting from the position theta is equal to 0 degree. Now if you read the problem, then they have given magnitude of the charge. So Q is the given. Q is 1 microcoulomb. So convert again microcoulomb into coulomb, which is 1 into 10 raised to minus 6 coulomb. Then they are separated by 2 centimeter. So distance small r is also given 2 centimeter. Again convert centimeter into meter. It is 2 into 10 raised to minus 2 meter. Now first we will calculate value of electric dipole moment, and electric dipole moment is P is equal to Q into twice L. Put the value of Q, which is 10 raised to minus 6, into what about 2L? 2L is 2 into 10 raised to minus 2 because separation distance between the two charges is 2 centimeter. So if you solve that value, you will get electric dipole moment 2 into 10 raised to minus 8 centimeter. Next, they are also given electric field of 10 raised to 5 10 raised to 5 Newton per coulomb. So we have a E is equal to 10 raised to 5 Newton per coulomb. So let us first calculate maximum torque. So torque is Pe sine theta, right? So value of P is known to you, value of E is also known to you, and maximum torque is to be calculated. So we are in the formula, sine is there, and when sine is maximum, when value of sine is 90 degree, then sine 90 is 1, which is maximum value of sine. So in the problem they have not mentioned theta, but you should take value of theta as 90 degree in order to get maximum torque. So put theta is 90 degree, and if you calculate, you will get torque is equal to 2 into 10 raised to minus 3 Newton meter. Second calculation for work. Now work is Pe inside the bracket cos theta 1 minus cos theta 2 bracket complete. value of P, value of E is in front of you. Put the value of P and put the value of E. Then inside the bracket, what about theta 1? Theta 1 is 0. And what about theta 2? Theta 2 is 180 degree. So cos 0 is 1. Cos 180 is minus 1. So minus and minus, it become plus. So we have answer 4 into 10 raised to minus 3 joule.